All right, we are beginning chapter 8. Chapter 8 deals with using exponents and exponential functions. Um, Today we're going to be starting with 8.1 and how we're going to apply exponent properties involving products. So there's two main definitions in this section that you have to keep in mind. The first one is the product of powers property, and the second one is the power of a power property. Um, product of powers property states that to multiply powers having the same base, which that basically means the same number or variable, if those things do apply, which means we can add the exponents. So like here in example A, I have a to the m power times a to the n power. That means that using the product of powers property, we can conclude that this can equal a to the m plus n power. And here's how it works with numbers. So let's look at b. So you have b here. So let's look at, you got 8 to the second power. That basically means that this equals 8 times 8. We have 1, we have 2. That's for 8 squared, or 8 to the second power means. Now we have 8 to the third power. This means that we have 8 times 8 times 8. Okay? And going back to what we used in example 1, if we have a to the m, which this is kind of like, if we incorporate this, would be like a squared times a cubed, we can conclude that if we add our two powers, 2 plus 3, this would be a to the fifth. And you get that, guys, just by counting the number of 8s we have. We got 1, we got 2, 3, 4, 5. And since they have the same base, same number of variable, we can write this as a to the fifth. Okay? So that's applying the product of powers property. Here we have what is called the power of a power property. And this is when you find a power of a power, you multiply the exponents. So here we have a to the m power, and then we have this parentheses, and all of which is to the n power. And so we're taking the power of a power, so this means, using the definition, this is what this equals to. So a to the m power, all to the n power, equals m times n. So looking at this here, we have a to the second power times all over to the third power. So let's look at this more in depth. If we have a squared, so let's put this in, so we remember from before, we have a squared equaling a times a. Okay? So we can rewrite this problem inside here as, in parentheses, a times a, all to the third power. Okay? Now this third power here gets attached to both 8s. So then this could equal a cubed times by 8 cubed times by 8 cubed. Then if we incorporate our product of powers property, we remember that we add the exponents. So it is a to the 6th. So that's where we can conclude that the power of a power property is by multiplying these. So you have a to the 2 times 3, which then equals a to the 6th. Okay? So now that we've determined what the product of powers property is and the power of a power property, let's do some examples. So these examples, they want you to, sorry about that. So for these examples, we want to be able to simplify the expression. And for these examples alone, there are some of this that they're going to ask you in your homework is they want you to write your answer using exponents. That means that, for example, let's look at A. So this is 4 to the 2nd power times 4 to the 6th. So using the product of powers property, we can conclude that 4 is to the 2 plus 6 power, which then equals 4 to the 8. Now that's what they mean by write your answer using exponents. See, this actually becomes a number. If you do take 4 to the 8th power, it comes out to be 65,536. But for these examples, we want you to leave it in exponent form. So let's look at B. We have negative 5 to the 7th times negative 5. Now what a lot of people make the mistake is people just write this as negative 5 to the 7th as their answer. But what you have to keep in mind is that even though negative 5 has no exponent attached to it, it still is negative 5 to the 1st power. So when you are simplifying the expression, you have to rewrite it as negative 5 to the 7 plus 1 power, which then if you add our exponents together, our answer would be negative 5 to the 8th. Okay? Here, we have 132 times 9 to the 6th power. Now, you can write this in two ways. Either way is fine. By leaving the answer in exponent form, you could do this. You could multiply 132 times 9, which gives you 1,188 to the 6th power. Then you just write it as 1,188 to the 6th power. That's one answer. Another answer you could do, which is perfectly acceptable, is attach the 6th power to both of our numbers because it's in parentheses, and to the 6th power deals with both 132 and 9. So another answer could be 132 to the 6th power times 9 to the 6th power. And that's both the same answer. I'll accept both answers. Okay. Here we have for D, we have negative 5 to the 3rd power, all of which it's to the 4th power. So now we have to implement our power of a power property, which then states that we have negative 5 to the 3 times 4 power, which equals negative 5 to the 12th. Okay. Now we're going to simplify the expression. This means that if a numerical value has numbers that you can realistically write down, it's not a big, huge number, I suggest you calculate that value. I'll show you what I'm talking about. If for a, I have x times x cubed. So we have to remember, using our product of powers property, we got x. Remember that this is to the first power plus 3, which then equals x to the 4th. For b, we have to remember we're going to use the power of a power property, which means that this could equal negative 10 to the, well, this is to like the 1 times 2, because this is like negative 10 to the first power, times x to the 6 times 2 power, which then equals negative 10 to the second times x to the 12th. But if we look at negative 10 squared, that's basically negative 10 times 10, which then that gives us 100 times x to the 12th. Okay, let's look at C. C is 6d squared times 2d to the 5th all over to the 4th. So let's just pay attention to this value here. Let's keep in mind that this square value is only attached to d. There's no parentheses that incorporates both of them, kind of like the 4th power here. The 4th power here actually is attached to both the 2 and to the d to the 5th. So when I'm simplifying this, I'm going to use 6d squared, just leave that alone for at the moment, times, I got 2 to the 1, because this is like 2 to the first power, times 4 multiplied by d to the 5th times 4. This is the use of the power of a power property. Now I can simplify the exponents inside the parentheses, so now I have 6d squared times 2d to the 20th. Okay, so now I have multiplication here of 6 times 2, so that gives me 12. And now I have same base of d, so that means I can incorporate the product of powers property, which means that this is d to the 2 plus 20, so then this can equal 12d to the 22nd. Last example. I got 3x to the 5th, all cubed, multiplied by 2x to the 7th, all squared. Now remember, that x to the 5th and that x to the 7th, that 5th power and 7th power are only attached to the variable x. It does not have any affiliation with the 3 or the 2. But our cube root here, our cube value and our square value do attach to both. So our 3 here would attach to the 3, and this would also attach to the x to the 5th. Our squared exponent here would attach to the 2, and it would also attach to our x to the 7th. So let's use the power of products property initially to solve for our inside our parentheses. So now I have 3 to the first times 3 power multiplied by x to the 5 times 3. So I'll leave it like this. And in the second parentheses, I got 2 times by the 1 times 2 multiplied by x to the 7 times 2. So then this can come out to be 3 cubed ends up being 27 because it's 3 times 3 times 3. And we got x to the 15th power multiplied by 2 to the second power. That's 2 times 2, so that's 4. And now we have x to the 7 times 2, which gives you 14. So 27 times 4 equals 108. And now we can use the product of powers property for our x to the 15th and x to the 14th. Since they have the same base, we got x to the 15 plus 14, which gives me x to the 29th power. And that is applying exponent properties involving products. Hope this helps. Until next time.